Dear student, I am Dr. Harel Thomas, Professor in Applied Geology, Dr. Harisingh Gour, Vishwavidyalaya, Sagar. Today, in this course, I will deliver my lecture on sedimentary rocks. Today, I will proceed under the following heads: Introduction, Sedimentary Rocks and Types. Hope it will be useful for you. Try to be regular in course. Rocks formed from material derived from pre-existing rocks by processes of denudation together with material of organic origin are sedimentary rocks. Natural agencies like blowing winds, running water, percolating underground water, glaciers in motion, etc., are in ceaseless operation, causing continuous wear and tear of the rock exposed to their fury. The production of such decay are subjected under favorable condition to sedimentation and subsequent compactness. The resulting rock masses thus form under ordinary pressure temperature condition are known as the sedimentary rocks or secondary rocks. Some of the most common rocks of this type are sandstones, limestone, laterite, coal, etc. The sedimentary rocks are of widespread occurrences upon the surface of the globe. The production of weathering may or may not remain at the spot where they were first formed. The insoluble residual material sometimes manage to avoid the transporting agency and hence accumulating in situ. At least for a certain length of time, the soluble substances are readily removed in solution and the more durable constituents like quartz travel in suspension with the surface runoff till condition favorable for their sedimentation are met with. The material thus transported either in solution or in suspension are capable of travelling to variable distance, ultimately to reach the sea. Whenever conditions are favorable, deposition may take place due to the settling down of the suspended particles of precipitation of the soluble constituents. The sediments thus formed continue to accumulate in suitable basin of sedimentation, and when accumulation is sufficient, the loose particles are gradually subjected to compaction and final conversion into sedimentary rocks. It is estimated that every year about 50 tons of dissolved matters and 300 tons of solid matter for every square miles of earth's surface are carried to the sea. Sedimentary rocks are deposited in layers one over another. The first form are at the bottom and the latter at the top. Sedimentology is the science that deals with the description, classification and origin of sedimentary rocks, and it is the study of sediments and sedimentation. The science of sedimentology is a relatively new and young discipline system, and the basic principle of sedimentology have been developed and refined by geologists for over a century. Depending upon their mode and mechanism of accumulation and consolidation, sedimentary rocks are classified into two main groups. They are clastic rocks formed from fragments of other rocks, and second, chemical rocks and biochemical rocks. Clastic rocks constitute particles of pre-existing rocks and minerals. These particles may have originally been from igneous rocks, metamorphic rock, or even other sedimentary rocks. Clastic rocks are deposited under the influence of some type of current, flowing water, waves, winds, or moving ice. Therefore, particle size in a reflection of the amount of energy that transported the sediment into the places of deposition and tells us something about how the rock was formed. There are three major categories of particle size, namely gravel, all particles larger than 2 millimeter in diameter, sand particles is smaller than 2 millimeter but larger than 0.0625 millimeter, and mud particles is smaller than 0.0625 millimeter. And first step in any identification of a clastic rock is to determine the grain size of the particles. If more than 30% of a rock is composed of gravel size clast, then it is either a conglomerate or a breccia. One should not forget that the shape of the grains in the rock is the important feature, not the shape of the hand specimens. This can be observed in conglomerate and clast, the clast which have rounded corners and the clast of breccia have angular corners. Remember, sandstone are clastic rocks and are made up of sand-sized particles, but not all sandstones are alike. The three common type of sandstones, sand particles, are quartz, feldspar, and rock fragments. If the sandstone is made up of mostly of quartz, it is called quartz sandstone or quartz arenite. If the sandstone has a significant amount of feldspar grains, it is called arkose sandstone. In order to differentiate between quartz sandstone or quartz arenite and arkosic sandstone, you must be able to tell the difference between the quartz and feldspar. Arkosic sandstone have a higher percentage of quartz but also contain identifiable feldspar grains. The final type of sandstone is made up of rock fragment. These may be places of basalt, shell, limestone, rhyolite, or even other sandstone, and the rock is called lithic sandstone. Orthoarenites, clastic rocks made up of mud-sized particles, have particles too smaller to see either shape of composition, or so classification is based on the particles of the rock as a whole rather than the grains or by particle size. Mud includes two subgroups. The coarse grains are silt 0.0625 millimeter to 0.0039 millimeter, and the finer grains are called clay, is smaller than 0.0039 millimeter in diameter. A rock dominated by silt particles is called a siltstone. A rock dominated by clay particle is called a clay stone. By now, you are asking yourself, if the particles are too small to identify, how I can tell them apart? Your eyes are less sensitive than your touch. Sandstone will feel gritty between your finger, but silt will feel smooth. Clay particles are so small that the particles even feel smooth on your teeth, a test which must be performed to be believed. Most rock in the mud family are made up of a mixture of silt and clay size particles. If these cases, if the rock show some degree of bedding, layering caused by gravity, then the rock is called shell. If the rock shows no evidence of bedding described as massive, it is called a mudstone. Figure on screen show common classification of clastic sedimentary rocks based on grain size. Chemical sedimentary rocks are deposited from aqueous solution, and precipitation may be caused by chemical or biochemical processes. The formation of chemical rock is not dependent on currents or energy, and particle size is not as important in classification as in clastic rocks. Instead, these rocks are classified on the chemistry of the dominant mineral. The three common groups of chemical rocks are carbonates, evaporites, and chert. Carbonates rocks are those composed of the carbonate minerals like calcite CaCO3 and dolomite MgCaCO3. Any rocks dominated by calcite is called a limestone. Although there are many different types, limestone are almost all formed under the influence of biota, organism living in the water. Some examples are clams, corals, and snails, which extract the constituent chemicals from the water to form their exoskeleton. When these animals die, they leave their skeleton behind, and those particles can become incorporated into the rock. More common, calcite is precipitated by the action of single-celled organism, algae, and geoplanktons. These microscopic calcite particles make up most of limestone. Limestone can be identified in the same way that calcite is identified, by the obvious reaction to dilute hydrochloric acid. If a limestone has no other distinguishing feature it is called either limestone or a micrite. Some limestone contain obvious fossil. These are called fossiliferous limestone. If a limestone is composed entirely of obvious and often large cell fragments, it is called a coquina. A limestone are composed of the tiny exoskeleton of algae is called chalk, and also be distinguished from a micrite because the chalk will feel somewhat gritty. Finally, some limestone are made up of small sand-sized spheres of calcite. These spheres are called ooliths and rock is called oolitic limestone. If a rock is dominated by the mineral dolomite, it is called dolostone. Essentially, all dolostone started out as limestone but have altered over the time. Therefore, it is possible to have most of the same feature seen in limestone. However, in most cases, when dolostone are formed, the original texture of the limestone are destroyed by recrystallization. So, most dolostone look like micrites or fossiliferous limestone. The key to distinguishing dolostone is to include the reaction to dilute hydrochloric acid. Evaporite rocks, in contrast to carbonaceous rocks, are deposited by chemical precipitation, not biochemical. They are classified by the dominant minerals gypsum, rock gypsum or albaster, and halite rock salt. These rocks form when waters becomes highly saline, such as Great Salt Lake in Urals and super sutured for these minerals. Normal ocean waters contain about 34,500 ppm TDS total dissolved solids. If the concentration reaches about 1 lakh ppm TDS, then gypsum will begins to precipitate from the water. At a salinity of 3,50,000 ppm, halides will begin to precipitate. These rocks are identified by being able to identify the constituents mineral. Chert, which contain quartz, forms under the temperature and pressure condition seen at the earth's surface. Quartz also form under metamorphic and igneous condition. Chert is a cryptocrystalline form of quartz with the same general properties but with a different mineralogical structure. Chert is often formed by biochemical processes. Certain type of algae called diatoms are capable of extracting silica from water, both freshwater and marine, and using it to form an exoskeleton. When the algae die, these skeleton can accumulate into a siliceous ooze layer, which when lithified form a chert layer or a chert nodule. In a marine environment, another silica producing organism is an amoeba type cell called a radiolarian. The marine environments, radiolarian together which diatoms contribute to formation of chert layers. Biological processes also can give rise to sediments, which can be result in the formation of sedimentary rocks. This typically occur in the ocean, where a variety of atoms float along the water molecules. Ions such as calcium, magnesium and potassium, along with trace elements like silicon, fluorine, iron and phosphorus, are used by marine organisms to form their hard and soft tissue. Once the marine plants or animal dies, it may settle to the ocean floor as biochemical sediments, then becomes compacted and cemented together into solid rock. Typically, only the hard skeletal part of an organism are preserved as sediments. Carbonates mineral do not accumulate on the sea floor, whereas the ocean is very deep because calcite is not stable at greater depths. If the water is deep enough, a falling shell made up of carbonate is dissolved back into the seawater. Another important biochemical components of many sedimentary rocks is hydrocarbons or organic compounds derived from living things. The decay of these materials in deeply buried sedimentary rocks produces oil, natural gas and coal. Only a few important rocks types form strictly by inorganic processes. Rock salt is made up of the mineral halite NaCl. It crystallizes when evaporation, concentration, sodium and chlorides ion to the point that salt is stable to the residual brine. Strong evaporation creates saline lakes in closed desert basin. For example, the Great Salt Lake and the Dead Sea. Enhanced evaporation also occurs in restricted ways along the shore of the ocean. Gypsum CaSO4 2H2O also originate from evaporation. It collects in layers as calcium sulfate is precipitated from water. Because evaporites rocks formed by evaporation accumulation only in restricted basin subjected to prolonged evaporation. They are important indicators of ancient climates and geographical condition. A natural agency of erosion, transportation, deposition and consolidation brought about development of sedimentary or sedimentary rocks. The study of sedimentary rocks are important to understand the paleo and present sedimentary environment. Types of sedimentary rocks and the classification of sedimentary rocks depending on their mode and mechanism of accumulation and consolidation into clastic rocks, chemical rocks and biochemical rocks, and discuss. For further studies, please read the textbooks, references and links given in the text. Thank you very much.